Hey everyone, today we're going to be looking at the go embed compiler directive, and that will allow us to embed our static assets and our HTML templates directly in our Go binary, which can simplify deployment. So we'll first look at the existing state of our program. We have just a single main package again. We have our templates being parsed, and we're ensuring that they parse successfully with the must. And then we have a shark struct with the species and population field. And then you can see we're just creating 4 sample sharks here and passing out as data to our templates when we call the home handler. And then we have a router, which is using new servmux. And then we just have a single home handler, as we see here. And then we just have our static assets being routed through the http.file server. And then we're just outputting that we're listening on localhost 8080, listening on all interfaces, and then we're panicking if that fails. And then our assets, we just have a single HTML file, which contains the title that's dynamically populated along with the range block of sharks, which is rendering a partial template, which is our shark template here. And you can see that it's just defining a shark and it's outputting the species and population fields as seen from our struct here. And then we have 2 assets. We have a shark picture, and then we have a data.text, which just contains hello world. And so, as you can see, we're on Go version 1.23.2, and then we're going to run our Go server on localhost 8080. We can go to our browser and just verify that this works. And you can see it's displaying correctly, and the assets are being rendered. We can just check that we can access data.text as well, and we'll see hello world. So great, we can go back to our main.go file now and consider how we're going to directly bundle these static assets and templates at build time rather than looking for them at runtime. Now, as you can see here, we have this router.handle for the static file server, and it's just directly looking at the dir of this assets directory. For instance, if we added an extra file in our assets folder here, it'll still parse it at runtime. When we use the go embed compiler directive, we'll have to ensure that all of our assets are already in the folder at compile time, or else it won't be bundled in the compiled binary. And the only other place that we are using relative paths is these HTML paths for the templates that we're passing to parse files. And so we're going to have to update both of those lines to use our new go embed directive. So let's go to the top of our file and define our first go embed, which is simply 2 slashes with no space, followed by a go:_embed, and then we're going to specify the folder we want, so we can put HTML, because we're looking to embed our HTML templates. And then we have to define a variable to store this embedded file system in, so we'll do a var templates. I like to do template fs, and then I do embed.fs here. This will import the embed package for us. So we can also embed our static files while we're here as well. So we'll define another compiler directive to embed the assets folder, and we're going to call it static fs of the type embed.fs. So now with these defined, first we need to update the template.parseFiles function. Instead, we're going to be using the template.parseFS function, which will accept as a parameter the template fs first, and then it will take the paths of the files you want to use. If we look at the function definition, we'll see that parsefs is just like parsefiles or parseglob, but it reads from the first parameter we pass, which is the file system fs, instead of the host operating system's file system. And we can pass glob parameters as well, but in this case, I'm just going to pass the 2 direct files that we need. And that's how simple it is to embed these templates directly in your binary. So if we restart our Go program and then go to our browser and refresh, we'll see it still works and nothing's changed. So we can go back to our code now and embed our static assets. And we're going to look for the file server function down here. And again, we need to update this because we're using our system file system rather than the embedded file system that we defined with the compiler directive. Now we don't need this http dir anymore, so we will delete this. And we can just put a http.fs of our static fs variable. And essentially what the http.fs function does is convert the fs.fs to a http.file system, which we can then use directly with the file server. As you can see, it accepts a root parameter with the http.file system type. So now we can save our file and restart our server and go to our browser. And then if we set on disable cache and refresh, we'll see we no longer get the shark image, it's returning a 404 not found. So if we try and view our shark image again, you'll see we're getting a 404 here. But if we go to assets/shark, it's there. So why is this the case? This is because when we're embedding it here, it's embedding the assets directory. So that leaves us with two options. Either we can change our paths in our template to use the /assets/shark.png file, or we can try to serve it directly from the top level directory. So we can do just /shark.png, like how our template expected. We'll do the second option just to demo how to do this. So what we can use is a cool function called fs.Sub. And you can think of that as doing something similar to a CD in Linux, where you're just moving into the directory. So you're only seeing what's relative to the current directory you're CD'd into. So I'll demonstrate this now. So I'll create a sub variable, and it also returns an error. And I'll check fs.Sub, and we'll see it takes two parameters, a static file system, and then the part of the file system we want to basically CD into or relatively move into. And if we look at the function definition of fs.Sub, we'll see it's simply returning a fs.fs as well. It's simply just moving into that subdirectory. And now we can simply check for the error, and we'll panic again for demo purposes. Again, this would only error right when the program is being run because it's in the main function, so a panic here isn't terrible. And then we can replace the static fs here, and I'm going to rename this to sub.fs just so it's clear that this is a fs.fs type. And then we can restart our server and go here, and we'll refresh. We'll see assets.shark.png should no longer exist because we're in the subdirectory, so it should only be shark.png. So we'll get a 404 not found, and then if we delete the assets and we go to shark.png, we'll see it exists. So our template should be working again. And if I go to 8080, and we'll see the shark is being rendered. Just to verify, we'll also check for data.txt, and we'll see that hello world is being displayed. And then if we try assets/data, we'll get a 404 not found. Now, it's pretty amazing how simple it is to embed these assets directly in your binary. There are a few caveats, however. Because they are built into your binary at compile time, you can't do dynamic file paths. If you want to do dynamic file paths, you probably shouldn't be using these embedded templates and instead should just use the normal parse files or parse glob, or for static files, the http.dir method. Also, you should take into account that the paths for the Go Embed compiler directives are relative to the current file it's being defined in. So because we're in main.go and assets and HTML are both directories in the same directory, which is the top level directory of our project, we can just write the single path here for them. However, if they were nested or we were embedding our files in a specific HTML or HTTP directory, for instance, then we would have to ensure that our relative paths align with our current file's path. This means that you are unable to use a parent directory, so we couldn't add two dots before to try and access the relative directory that's a parent. However, you can do anything that is a subdirectory, so you could have a nested directory. And one last thing is that these embed paths accept globs. So if we only wanted shark.png to render, we could do /shark.png, or we could also do a glob with a star. And we can restart our server just to test that out. And so we should expect /data.txt to now be 404. And we'll see that's exactly what happens. And then if we try shark.png, it should still work. And we see we're still getting our shark. So we can go back. And the final thing I want to show is the fact that you can build this binary now and it can be run anywhere. You don't have to be relative to the assets or HTML folder because they're no longer being referenced at all. Instead, we're using the virtual embedded file systems that we defined. So I'll just remove this PNG glob, and then I'll rebuild our binary. This time, instead of running it, I'm going to run go build, and that'll output a sharkbite file in our directory here. That is a binary that we can run, and I'll just simply move this to our temp folder just to test it out. So if we ls sharkbite, we'll see it's now in our temp directory, and we can just run temp sharkbite, and now there's no HTML or assets directory in our temp folder. If we run it, we'll see it's still serving on localhost with no issues. And then we'll go to our browser. And if we go to localhost 8080 again and just click enter, again, I'm disabling the cache. And we'll see that it's returning successfully and it has our templates and static assets fully embedded. Now that's the gist of what's possible with this compiler directive. I think it's very useful, especially if you want to simplify your deployment. All it would take is a SCP or rsync command to move this file over to a VPS, which you can then run it using something like systemd. Even if you're containerizing your application as well, it still makes it simpler because you no longer have to worry about copying over your static files and templates. And if you want to reduce complexity and just have a simple application that's easy to deploy, I think this is a great way to go. Although again, it depends on a case-by-case basis what's always best for your project. Anyways, I hope you guys enjoyed this video. Feel free to leave any questions or comments below, and if not, I'll see you in the next one. Thanks for watching.